on page 52 of your workbook, and we're going to do a catch-up type problem. Example 4.20, a man travels 5 miles per hour. After traveling for 6 hours, another man starts at the same place, following at the rate of 8 miles per hour. When will the second man overtake the first? So we're looking at finding time, right? So we're going to let t equal the time of the second man because that's what we're trying to find. And we know the times are different because they start at different spots. So we're going to 6 equal the time of the first man because we know he took longer, 6 hours longer because he had that much of a head start, right? So we have our little drawings we'll put on. We have person 1 sets out going along, and they're going 5 miles per hour is the rate. Then we have the second person going along. They start delayed, but they're going faster, 8 miles per hour. And we want to know when their distances are equal. So we have distance 1 is right here. Should keep that in that color. So that's distance 1. And distance 2 is for the 8 mile per hour guy. So the thing we have missing here is our time. So distance 1 will equal 5 miles per hour for person 1 times the t plus 6 over here. And then the 8 mile per hour person is just our times t. So then we can set up our equation to be 5t plus 6 is the distance for the first person, which will be equal to 8t, representing the distance for the second person. And now just solve for t by distributing. And you can pause the video and just finish that out on your own. Now we get an answer of t equals 10. Well, what's that represent? That represents the time of the second man that it takes to overtake, right? So we're done there. Just write that in a sentence. So that was part C. Part D is our sentence. So here we have it will take 10 hours for the second man to overtake the first man. So these are very similar to the ones you did before, but again, everyone has like a little bit of a twist. So make sure you're looking into that. Sometimes these are not like added on times. It might be like twice as fast or something like that too. So keep that in mind. So now we'll look at example 4.21. Trey started biking to the park, traveling 8 miles per hour. After some time, the bike got a flat, so Trey walked the rest of the way, traveling 5 miles per hour. If the total trip to the park took 7 hours and it was 47 miles away, how long did Trey travel at each speed? So I'm going to draw a little picture here. We have our bike path. Here's the little bike. Oops, that's a little long. Okay, let's fix that. There's a bike and little handlebars. Okay, and he's on the bike right now, right? Pedaling along, and then we know he's going at 8 miles per hour there, and then he hits a flat, right? Gets his flat. And the time it took to get there, we don't know, right? We don't know. Time is question mark. So we have to think about that. We know the whole time took 7 hours. So we're going to say let t equal time on bike. And then if we have the whole thing is 7 hours, we would have t, or 7 minus t, is the rest, right? Equals time walking. And what pace was that? We were given that info here, that it was 5 miles per hour walking. Okay. And we have our distance is what we are trying to, let's see, what's my distance? Is 47 miles away. Okay, so here's start, and then here's the park. Okay, so all together, the distance is 47 miles. So the time or the distance that he spent on the bike would be 8t, distance bike, is represented by weight times time, plus distance walk would be my 5 times quantity 7. I just want to write that t first. 7 minus t equals total distance, and we are given that information as 47. Now that lays out, it's very similar to the other problem we did earlier, kind of like the first one in the other video, 4.18, except our times are not the same. We have a different relationship there, so be careful of that. You do have to adjust for that because it took a piece of the time was spent on the bike, and then a different amount of time was spent walking. So be careful of that, not to just put it T for both of those. And then you're going to distribute and solve. So go ahead and finish that one out. So we're almost done. We just need our sentence here. We have T equals 4. Well, what does that represent? We can look up here. That's the time on the bike, right? And we want to know how long did Trey travel at each speed. So we have to make sure we include all that. So Trey biked 8 miles per hour for 4 hours and walked 5 miles per hour for the remaining time, which we can just kind of figure out in our head, or we can look back up here. 7 minus 4 equals 3, right? So for 3 hours. Okay, so a lot of activity for Trey to get to the park. It's a pretty far ride. Hopefully someone helps him out on getting back that 47 miles. And that's it for the uniform motion problems. I'm going to do the mixture problems on a separate video. So thanks for watching. Let me know if you have questions. Have a great day.